In this video, we're going to look at the definition of the radian, which is another way to measure angles. So you're probably very familiar with the unit of degrees. So, up until most of high school, we measure angles in degrees, and they're based around the number 360. So the reason for that is the Babylonians and ancient people used that as their basis, and in some ways it makes a bit of sense, right? 360 has a lot of factors, so it's you can split it up into different fractions, and you'll get a whole number, which is really nice for when you're talking about something like angles. But it doesn't actually have a very good mathematical basis in that, in terms of the circle, the number 360 is not special. So what we're going to use now, we're going to use radians to measure angles, and the reason for that is they're actually based on the circle, so it's a bit more of a natural unit, and it actually makes some of the maths easier. Now, we've got the definition here that 1 radian is the arc length around that is 1 radius of that circle. So here we see that the radius is, in red here, from here to here, about that distance. And if you're to go around the circle, that's from there to around there. And that should be the same distance. Now, the thing that is nice about that is, say you had a bigger circle, like something like that. I mean, just use your imagination to imagine that circle. You could tell that for this circle, the radius is much bigger, right? It's all the way out to about there. So, but the good thing about the radian is that if you were to measure around, it should be, if you go 1 radius around, because the radius has got bigger while the circle has got bigger, you can see that the angle actually hasn't changed. So basing our unit for angles on the circle itself is actually a really nice thing to do, and it's what we're going to use. Now, if you wanted to think about converting from degrees to radians, you could think about the fact that, well, if you go all the way around your circle, that the circumference is 2 pi r, and we could tell before here that it didn't actually matter what your radius was. A radian, the amount you've gone around, is the same no matter what the radius is. So we can just pick a value of r as 1. That's going to make the math a bit easier. So we can see that going 360 degrees, that's how you go all the way around in degrees, is the same as 2 pi radians. So then you can do a bit of maths here and get a conversion factor from radians to degrees and degrees to radians. Pi, not the word pi. And if you go from there, you can get these conversion factors. So if ever I want to go from degrees to radians, I multiply by pi on 180, and it's the reciprocal for going the other way. So going from radians to degrees, I multiply by 180 on pi. The way I remember that, to really make it easier for me, so say I had about 60 degrees. Well, I know that as you get more used to using radians, you realize that almost always they have a factor of pi as a numerator of some fraction. So I know that I need pi in my numerator on the top. So then I know that I'm going to have to times by something where pi is on the top, and I know that my other number in my conversion factor is always 180. So when I do this conversion, I times by pi on 180. So I'd get, what I think that goes into that 3 times. So I'd get pi on 3. Conversely, if I had some measurement of angles in radians, it's going to be something like maybe pi on 6 with pi on the top. That's what we're used to seeing, or at least we're going to get used to seeing. So I know that I'm going to have to get rid of that factor of pi on the top, because I know when I'm measuring things in degrees, typically there's no factor of pi. So I'm going to times by something with pi on the bottom so that these pi's cancel. And then my other thing in my conversion factor is 180. So it must be 180 on the top. The pi's cancel. That goes in there. Well, it goes into 180 30 times, or you could think about it, 18 is 6 times 3. So you get 30 degrees. Now, another way to do it, which I actually don't really use these conversion factors that much. For me, the quicker way to do it is to just think about circles. So if I draw myself a little unit circle here, circle radius 1, I know that to go to 90 degrees in the positive direction from x, we go up to here, right? We have our right angle. So if I know that all the way around, when I go all the way around, that's 2 pi radians. If I go half the way around, that is pi radians. which I also know to be 180 degrees. So if I'm only going to 90, well, 90 is half of 180. So to go to here, I'm going pi on 2 radians. Yeah? And then likewise with 45 degrees, well, I know 45 degrees is half of 90. So I just take my pi on 2 that I got for 90, times it by a half, and I get pi on 4 for 45 degrees. Then with 3 pi on 2, that one, maybe I just use my conversion factor because maybe I can't quite see how that's going to be. Then again, actually, I'd probably just think about it. Well, I know 3 pi on 2, that's pi plus pi on 2, right? So I know pi is 180, pi on 2 is 90. So it's 180, which is half the way around, and then 90, another quarter. So it's around here, it's 270 degrees. Finally, 6 pi, well, I know 2 pi is all the way around. So then if I go all the way around again, that's 4 pi. And if I go all the way around again, that is 6 pi. So I've gone round all the way, 360 degrees times 3. So that's what? So times 2 would be 720, times 3 would be 1080. And there you go. So that is how we convert from degrees to radians and vice versa.